Hello, we are on 9.01 today, so we're going to start a new unit in pre-calc, and should be almost all review for you today from geometry. I know you all miss it, so here it is. So we're going to be talking about circles today, and as you can see here, I've got two double wrapped cones. And it's just like two cones that meet right at that top point, that apex. And to get the conics that we're going to be talking about, you're just taking different slices of these double wrapped cones. So today we're talking about the circle. So we're taking a slice right here from that double wrapped cone. So parallel to the base of your cone, and the base of a cone is a circle, so that's what gives us a circle. The equation of a circle with a radius r and center hk, and again, this should be review from geometry, is the quantity x minus h squared plus the quantity y minus k squared equals r squared, where hk is your center. Remember, you take the opposite signs of those, and then r represents your radius. If we know that the origin is the center of the circle, so if that's your h and k, then our equation would just be x squared plus y squared equals r squared, because h and k would just be 0. Number 1, find the equation of a circle with the endpoints of the diameter at -1, 2, and 5, 6. So in order to write the equation of a circle, we need two things. We need to know the radius and we need to know the center. So in order to do this problem, we need the center and the radius, which we don't have either of at this point. So we need to find those. So what we're going to do is we're going to find the center first. So we are going back to geometry formulas as well, our coordinate geometry formulas besides our circle formula. And the center is going to be directly between these. So let's go ahead and plot them just to get a visual on what we're talking about here. So we've got the point -1, 2, and 1, 2, 3, 4, 5, up. Oh, I don't think I go up 6 here. So let me just erase that one. Ink pens, erase. And let's count by 2s on our axis. Make these a little thinner. So 2, 4, 6, 8. Change the color, make it a little thicker. And now I'm going to go -1, 2, and then 1, 2, 3, 4, 5, and up 6. So I'm counting by 1s here and by 2s along the x-axis. So that's our diameter, which means if we were to draw a circle, not a very good circle, but it would pass through both of those endpoints. And our center looks like it's going to be somewhere about here. For these, I want them done all algebraically. So even if you can figure out, which I'm sure most of you can figure out, the exact coordinates of that using right triangles to find the center, I want you to show the formulas when you do it over here. So we're going to use the midpoint formula because we want the midpoint of our diameter. So remember, your midpoint is the average of your x's and the average of your y coordinates. So we're going to call this our x1, y1, this your x sub 2, y sub 2, and we're going to just substitute in. So I'm going to have -1 plus 5 over 2 and 2 plus 6 over 2. Combine those, 5 minus 1 is 4, 4 over 2 is 2, 2 plus 6 is 8, 8 over 2 is 4. So it looks like I plotted it right on the exact point there, so the 0.24. So we verified that. So that is going to be our H and our K. Okay, next, we're going to find the radius. So that was our center. So our radius is the distance from the center point to one point on the circle. There's a couple ways you guys could do this. You could find the distance of the entire diameter and then divide that by 2. Or you can just find the center first and then find the distance between the center and a point on the circle. From the center to a point on the circle. That way you don't have to deal with any, if it's a radical and you don't have to square the radical after you divide it by 2, it's just often easier to just use that new center point and one of the points that was given. So to do this, you again have a couple of different options. Obviously you can check it using your right triangles on the grid, but that's not algebraically. We're going to do it using the distance formula. I'm going to show you first, and then I'll show you another way as well. The other way uses, I made a plus instead of a minus. The other way uses the fact that the distance formula is actually the circle formula. Because if you were to square both sides of the distance formula, you'd get your circle formula. The radical would go away. X minus h squared plus y minus k squared equals the d, which would be your r squared. All right, so to find our radius, gets confusing when you call it d because you think diameter. So I'm going to say radius equals, and I'm going to substitute in. So I'm finding the distance of my center, which is 2, 4, and I'm going to use the point, the first point I was given, -1, 2. So here I'm calling this my x sub 1, y sub 1, x2, y2. So I'm going to take x sub 2, which is -1, minus 2 quantity squared, plus 2 minus 4 quantity squared. Gives me -3 quantity squared, plus -2 quantity squared. Make sure those, since they're negative, must be in parentheses. 9 and 4 gives me rad 13. All right, so now I've got enough information to write my equation of my circle. So I'm going to take x minus h, which is 2, quantity squared, plus y minus k, which is 4 squared, equals, my radius is rad 13, squared gives me just 13, will be my answer. Now I want to just go over real quick here another option that you can do. So you could also say, well, once I find the center right here, I know that's x minus 2 quantity squared plus y minus 4 quantity squared equals r squared. So instead of using the distance formula, you could just sub in your point right in here for your x and your y. So say, well, x I know could be -1, and you could use either point it would work with. The 2, y is 2. And this is really just the same thing as doing the distance formula. You'll see here, we get -3 squared, -2 squared, 9 and 4 gives me 13. So I already have the r squared, which goes right into that equation. Okay, so either way is fine with me, but I do want it done algebraically. You can check on the graph by saying, okay, well, I went up 2 boxes, I went over 3 boxes, and then do your Pythagorean theorem. 2 squared plus 3 squared is going to equal our r squared. And again, 4 plus 9 gives us 13. All right, number 2, I would say here would be a good point to pause and do whatever way you're more comfortable doing. So I'd like you to do it algebraically though. Find your center and find your radius. Again, radius, you can do distance formula or you can substitute in. Go ahead, pause, and then I'm going to give you the answer. All right, so from your midpoint formula, you should have gotten that your center was at 3, 3. You should have gotten your r squared should be 8. Depending on how you did it, you might have found r first, or you might have found r squared, but your final answer, either way, should be this. And if you are struggling with these and you do need more help, please let me know. We can set up a Google Meet, or you can send me some work and I can check it for you. Number 3, identify the center and radius and graph the circle given by the equation. Then we're just doing a rough sketch of our graph because we don't have a compass. Also, with the last two, those were just, the grid was just given as an optional grid. You didn't have to graph it on those. All right, so first thing we're gonna do is group your X's and your Y's together, which in this case, ours are already kind of in that order. So I'm gonna group them with a blank, X's and Y's, and then I'm also going to subtract anything that doesn't have an X or a Y. So we call those a constant. Subtract any constants to the right side. Okay, so that's step number 1. So I've got x squared minus 6x. I'm gonna leave a blank right here and kind of group those, plus y squared minus 2y blank. And then I'm gonna subtract this 6 over to the other side. Now what we're gonna do is we're gonna complete the square for each X and Y group. So complete the square for X and Y. So to do that, so we're looking at the X's here. We're gonna remember your formula for completing the square is B over 2 quantity squared. So I'm gonna take for my X's, I'm gonna take my B, and you always use your new B if you have factored anything out. So I'm gonna take my negative 6 over 2 quantity squared, which gives me negative 3 squared, which is 9. I'm gonna take that, and some of you, I know Mrs. Locke uses the B box. She boxes that up. It looks something like that, I think. So I'm gonna add in my 9 over here. If I add 9 on the left side, I have to add 9 on the right side. Now let's do it for the Y's. So B over 2 quantity squared. This time my B is negative 2. And that's negative 1 quantity squared, which is 1. So I'm going to add 1 here, and I'm going to add 1 here. Next, we want to rewrite these as perfect squared binomials. So this green set of X's, I'm going to rewrite as X. So a couple different ways you can do this from completing the square. You either look, what was it before you squared it? So it was minus 3. You could think it's always B divided by 2. So negative 6 over 2 is negative 3. Or think to yourself, what would multiply to 9 and add to negative 6? Negative 3 and negative 3. And then our Y group, going to do the same thing. So whatever it was before I squared it, so it was negative 1, so it's y minus 1 quantity squared. And then I have 9 minus 6 is 3, plus 1 is 4. So I now have my equation. It asked me to identify the center and the radius. So to find the center, you want to take the opposite signs, remember? So it's like your parent functions when you shift. So inside the parenthesis, it's opposite of what you think. So we'd go right 3, up 1. And that's our center, and then the radius is going to be the square root of what it's equal to. So square root of 4 is 2. And then it says graph. So when you graph a circle, you're going to put your center there first. So 1, 2, 3, 1. So again, you're moving from 0, 0, right 3, up 1 is your center. And our radius is 2, so I'm going to count 2 boxes to the left, 2 to the right, 2 up, and 2 down. And since we don't have a compass, we're just going to kind of do a rough sketch there. And, oops, minus, erase that, label it with the original equation. Minus 6x plus y squared minus 2y plus 6 equals 0. And that's it for number 3. Next, number 4, identify the center and radius given by the equation. So for this one, there's just a different first step. So I'm going to start this off with you. Because you have a 2 in front of both your x squared and your y squared, we're going to start by dividing both sides, everything, by 2. As we go on into the conics unit, it's going to be really important that when you see this original equation, that you can identify that this is a circle. So one of the reasons why you'd be able to tell this is a circle is because it has an x squared and a y squared. So circles always have x squared and y squared. The other thing is they should be added together. So they're both going to be positive, both positive x squared and positive y squared. And they have to have the same number or the same coefficient for x squared and y squared. Okay, so positive x squared, positive y squared, both are being squared and they have to have the same coefficient. That's what tells us this is going to be a circle. All right, so I'm going to divide everything by 2, which now gives me x squared plus y squared minus 2x minus 4y minus 4. 0 divided by 2 is just 0. Next thing you want to do is kind of group your x's together here. It makes it a little easier. So x squared minus 2x plus, take all my y's, y squared minus 4y blank, and then any constants get added over right at the beginning. Okay, so here would be a good point. Once we've gotten to here, pause the video, see if you can complete this all on your own. You want to get the equation and then identify the center and the radius. Okay, so you should have found your b over 2 quantity squared. Would have been 1. Here you would have had positive 4. Make sure you add them to the other side. Kind of going through relatively quickly here. Rewrite them as perfect squared binomials. Add up the right side. There's your equation. Your center, then you take the opposite sign. So it'd be positive 1, positive 2. And your radius, square root of 9, would give you 3. Number 5. Find the x and y intercepts of the graph of the circle given by the equation. Answers in simplest radical form. And again, the grid for this one is optional. So let's find our x-intercept first. So the one thing you want to think about when you're on the x-axis, what is your value for y? Well, you haven't gone up or down at all. So anytime you're on the x-axis, your y is going to be 0. So I'm going to take my equation, and everywhere I see a y, I'm going to put a 0. So x minus 4 quantity squared plus 0 minus 2 squared equals 16. And that gives me 0 minus 2 is negative 2. Negative 2 quantity squared is 4. And I'm going to isolate this x minus 4 quantity squared now. So I'm going to subtract 4 from both sides, which gives me 12. Now I want to solve for x, so I'm going to isolate that. So I'm going to take the square root of each side to get rid of that squared term. Anytime I take the square root, I need to remember plus or minus, negative to negative. While I'm at it here, I might as well put this into simplest radical form. Largest perfect square I can take from 12 is 4. 4 times 3, so now I have x minus 4 equals plus or minus 2 rad 3. And I just need to add 4 over to both sides. You always want to write that 4 first. So 4 plus or minus 2 rad 3. So there are 2 different x-intercepts, and when you write intercepts, they should be written as ordered pairs. So 4 plus 2 rad 3, 4 minus 2 rad 3, and the y-coordinate is 0. So those are your x-intercepts. Now let's talk y-intercepts. So anytime you're on the y-axis, you're going to have x equal to 0 because you're not going left or right any. You're staying right on that axis. If you don't get that, try subbing in some points. So this would be the point 0, 1, 0, 2, 0, 3, 0, negative 1. Notice all of the x values are 0. So we're going to put in a 0 everywhere we see an x and keep the y this time. So we get negative 4 squared is 16. And I'm going to subtract 16 from both sides because I'm isolating that y value. If you were to FOIL it, it just makes it too hard because then you have a y squared and a y. So the easiest way is to really isolate this binomial squared and then work to get inside of it. So take the square root of each side. So y minus 2 equals plus or minus 0. Well, that's just 0. Add over your 2. Y equals 2. So there's only going to be one y-intercept, which is at 0, 2. So the whole circle will end before that. Because if you get an idea here, you graph this 1, 2, 3, 4 up 2. Then your radius is the square root of 16, which is 4. So 1, 2, 3, 4. So it hits right here. 1, 2, 3. It's going to go over here. 1, 2, 3, 4. 1, 2, 3, 4. So you have your circle like this. So it's tangent to the y-axis right there, but it will hit the x-axis 2 times, but not at nice numbers. They'll be irrational. And simplest radical form, so we're good. And that we didn't have to count by 2's along your x-axis because it was just an optional grid. We're just getting an idea of what it's going to look like. Okay, and number 6. So this is kind of combining everything together. The last couple things we did. So I want you to find the x and y intercepts of the graph of the circle given by this equation. So first, put it in simplest radical form. The grid is optional. So you first want to put it into standard form, then find your intercept. So it's going to be just like the one we last did, number 5, once we do that. You could also just sub in your x and y now, but I want you guys to be able to get a visual of what it's going to look like and look at the graph of it too. So let's practice everything this time. So first thing I'm going to do is x squared plus 8x. Again, notice we know this is a circle because there are the same coefficient in front of x squared and y squared. They're both being squared and they're being added together. Subtracted my 9 over from both sides. Now I'm going to do my x term for completing the square. So b over 2 quantity squared, 8 over 2 squared, 4 squared, which gives me 16. Add that to both sides. Do the same for my y's. So I've got 2 over 2 quantity squared, which is 1 squared, which is 1. Add 1. Add 1. Rewrite the x's as a perfect square binomial. So whatever it was before you squared it, positive 4. Then do the same for the y's, whatever it was before you squared it. So plus 1, or think what times itself gives you 1 and adds to 2. 16 minus 9 plus 1 gives us 8. Now we have this equation. You should be able to, at this point, recognize that your center is -4, -1, and your radius is the square root of 8, which is 2 rad 2. I didn't ask for that, but that's things you should be able to give me. And lastly, we want to find your x-intercepts and your y-intercepts. So x-intercept is where y is equal to 0. So we're going to sub in 0 in for y, equals 8. So that's x plus 4 quantity squared plus 1 squared, which is 1. Subtract your 1 gives us 7. Take the square root again. Don't forget your plus or minus whenever you take the square root. 7 is already in simplest radical form, so we're just going to subtract over the 4. But when we're asked for intercepts, really important to rewrite them as ordered pairs because an intercept is a point. So there's 2 x-intercepts again for this one. Y-intercept is where x equals 0. So this time I'm going to put 0 in for x and leave my y. So 4 squared is 16 plus y plus 1 squared. Subtract over our 16. Gives us -8. take the square root. Uh-oh. When we take the square root, it gives us an imaginary number. It gives us 2i rad 2. And since this is imaginary, that tells us it's not going to touch the axis. So there are no y-intercepts because it's imaginary. So we can stop right there. We only have x-intercepts for this one. So as soon as you start to see that it's going to be imaginary, you can stop and say that there are no y-intercepts because it is imaginary. All right. And that is the end of the 9.01 notes. I hope you're all staying healthy, loving math, and Pi out.